So as we're talking about data visualization and how to do this well, I think it's useful to have a conversation about first principles, things that we should always keep in mind, and rules that we should violate rarely, if ever, and at our peril. So the first principle that I'll begin with is just accurate presentation of data, that the purpose of data visualization is to communicate useful information to people in a way that they can quickly and easily get meaning out of it. And that means we present things in a way that fairly and accurately shows what's going on and helps communicate that important piece, right? And so the Economist magazine does lots of different creative, some would say terrible, data visualization strategies with their graphics. And this is one where they got themselves in trouble, where they were showing social media likes and engagement for various different entities in sort of the British political system. And they want to communicate that Jeremy Corbyn is doing really well relative to other potential sites on Facebook that could get likes. And I guess they highlight that by making on the sort of left-hand side, by making Jeremy Corbyn's bar maroonish, and everybody else is sort of a lighter orange. But they also kind of communicated the bar chart, which suggests that we can look at the length of the bar and get a sense of the proportion, how distant things are. But because The Economist does this little sort of truncation thing on that Jeremy Corbyn bar, the proportions that you get when you just glance at this graph are completely wrong. Now, they're not necessarily trying to be fully misleading, right? They've sort of indicated that we're off the scale, and here's the number value that goes with it. And if you drilled in and really, study this graph, you get the correct information, but it's not presented in a way where that's immediately obvious, and somebody glancing at it is going to recognize what's really going on. Whereas in the second graph on the right, it's very clear, like instantly it's clear how much more engagement Jeremy Corbyn is getting over all other sort of British Facebook political pages that might be considered, right? So accurate presentation of the data isn't just sort of we bury the details in there and people can find them if they dig. It's when you glance at it, can you see the correct pattern and intuit the correct pattern of what's happening? This is another example, it's sort of a famous example of just really ridiculously bad data visualization. It's from a French newspaper in the 1920s, talking about French exports of automobiles to French colonies. And it was really important for the newspaper folks to indicate that their colonies are made up of people who wear different sort of attire. And that's really what this graph is about. It's about showing different ways that people dress with numbers thrown on it, because we're trying to show years, but the numbers have no meaning and don't correspond in any way, shape, or form to the size of the figures. And this is something that really happens a lot, that whenever people try to use pictures in place of bar graphs, it almost always distorts proportion in a way where the size of the picture does not really correspond to the numbers involved. And if you kind of look at sort of how things play out, you see that really quickly, that the third sort of individual in Tunisia is sort of sitting at almost 3,000, whereas the first sort of picture of a person for Algeria is well over 6,500, and yet the difference between them is negligible, which is, again, a ridiculous way of presenting information, because you look at it and you can't have any sense of the proportions of the numbers. You're just getting a visual about colonies. This is another example of people using just really bad decisions in terms of data visualization that make it almost impossible to get a sense of what's happening. And so if I'm looking at this graph, the first thing I'm going to look at is like, whoa, some of these bars are like way bigger than the other. And I'm going to look and I'm going to see that the Saab 900 and the Volvo 260 are sort of these like, really doing well in terms of, I guess, cars. But that's not actually what this graph is telling us about. This graph is telling us about the national origin of cars. And it has nominal categories: USA, Japan, Germany, France, Sweden, across the bottom. But those are nominal categories and they can be placed in any order. And so the length of the bars has no corresponding meaning other than we put Sweden in the last category, and therefore Swedish made cars are going to have this longer bar that indicates that they're Swedish-made cars. Is a terrible graphic. And it's terrible not just because you're using nominal data and a way of communicating that in a way that just doesn't work, but it's a terrible graphic in that you look at it and you immediately come away with conclusions that don't map at all to what the data is actually trying to communicate to you. Okay, so a second kind of related element I think it's worth pointing out, because this is something that people get kind of picky about, is, and this is my view, is that it is okay to truncate the axes, because the goal of data visualization is to give us a story and make that story clear to people in a way that's not misleading, in a way that they can get all the information that they need, in a way that's sort of immediately obvious. And so if we're looking at sort of the first two kind of grayish graphs, they're showing the same information, but in one situation, the y-axis has been truncated. So the first one, it goes from 0 to 150 and covers the full range of numbers from 0 to 150. Kind of an arbitrary sort of thing. And the other one, it goes from 95 to 115, which is also kind of arbitrary, except that sort of zooms in on the relevant change in these values over time, which is maybe what we're interested in seeing. And so you might say, well, isn't that misleading? You're making sort of what's a really gradual change look like a dramatic change. And I would say, well, is it a gradual change? It only looks like a gradual change because we've made a decision to put it on this scale. And I can make it look like an even more gradual change by increasing my upper end of that scale to 300 or 1,000 or 10,000. If I have a scale of 10,000, the change is going to be almost imperceptible, on any way, shape, or form. Whereas if I zoom in to sort of see, okay, here's the range which things are bouncing around, and we do see this trend upward, at least you can pick that up very quickly. I would also point out that we frequently truncate our x-axes, right? Why is it that it's okay to start this conversation in 1990? What happened to all the data going back to 1900 or to the year 0? Right? We obviously don't do that. We don't include all the way back to 0 or all the way back to 10,000 BC. We say this is the range that we're interested in looking at and communicating information about, and that's what we're going to present in that graph. And I think that the same rationale applies when we're thinking about the y-axis in these situations as it would apply in the x-axis. Now, people do get testy about this. They do feel that sometimes when you truncate the x-axis, you are trying to pull a fast one on people, or be misleading. One strategy is to try to make that very clear that you're truncating that x-axis. And so I like what this third graph did. It starts the axis at basically 100 instead of 0, and to sort of communicate that, they sort of put these little hash lines in there that says, yeah, we're just like deleting out white space. There's nothing happening in this area that you would want to pay attention to, so we're just going to compress it, and we're telling you that we're compressing it. And maybe that's sort of a nice middle ground, but I think it's always worth keeping in mind when thinking about those decisions about whether or not you're going to show the white space or truncate your axes, what makes most sense to communicate the relevant information to your audience. Okay, a second first principle is the idea of max info, minimum ink. And this is the idea that you want to communicate lots of information to people, but you don't want to do it in a way that's cluttered, in a way that's chaotic, in a way that uses more ink than is necessary. And so if you're going to use color, that color should serve a purpose. If you're going to have lines, those lines need to be helpful to be able to understand what's going on. And so I think a useful distinction is, the graph on the left versus the graph on the right, communicating the same information. The graph on the left looks messy. We've cleaned it up. We've taken away a lot of stuff that wasn't really necessary for communicating the information there, but certainly took up a lot of ink. And so when we kind of keep that idea in the back of our head that we're trying to communicate the information, but not do so in a messy or cluttered way, we can kind of revisit different data visualization techniques and maybe think about their pros and cons. So we could look at box plots, and box plots are oftentimes considered a very efficient way of showing a distribution. I can draw them up fairly easily. They don't require a lot of ink. We can even do them on dot matrix printers if we were still in the 1980s. And so they're very handy, but they also don't show a lot of information because they don't show the distribution. They just show the quartile ranges and where the median is. And then occasionally if there's an outlier. So some people would argue that a violin plot shows more information about the distribution of the data. And so you could think about the sort of curves on these violin plots as sort of representing where there's more cases when the sort of curves bulge out and fewer cases when it goes in, but that's involving a lot more data than we had before. So maybe we want a stream plot where we're just showing where the dots fall. And we can kind of get a sense of the distribution. We can kind of get a sense of where they're clustering. We can use a little orange triangle there to indicate this is the median point, whereas before we used a solid line with the box plot or a little white dot with the violin plot. And so with the stream plots, we're getting potentially all the same information, but doing so with very little ink and something that is reasonably easy to understand and interpret. I will flag, however, that there is sort of an obsession with new graphs within the data visualization community. And so there's a lot of, I don't say buzz, but people tend to use this Raincloud Graph, which does all of those things that we saw in that last page. It has a box plot in it. It has a violin plot, or at least half of a violin plot. And then it has the sort of stream plot. And it looks kind of visually interesting, like there's a lot going on there. But the truth is that you're using 3 graphs to communicate the exact same information, how this data is distributed. And any one of them would probably do well enough. And so we're kind of violating that idea of maximum information with minimum ink, and that we're not really providing any additional information, but we're adding a lot more ink into that conversation. And it makes for kind of a messy plot. So I'm very much not a fan of the Raincloud graphs. First principle for data visualization is this idea of hierarchical presentation, and we'll talk a little bit more about this when we talk about infographics. The basic idea is that you should be able to see the main idea very quickly. Right? It should just pop out at you, and you should think about color, and you should think about size, and you should think about maybe borders to draw your attention in on the very first thing that you want people to pay attention to. Right? So that first bar chart, I'm picking up that the first bar, the cards bar, is the largest, and the MP3 bar is the smallest. Right? I picked that up very quickly. In the second one, I've added an additional element into that, which is the confidence intervals around those ranges. But I've added that in a very subtle way with just this little extra line. And it's just enough that I'm not going to lose what I saw initially. Like I'm still going to focus in on the cards bar is the largest and the MP3 bar is the smallest. But if I spend an additional couple seconds looking at that graph, I'm going to notice those extra lines. I'm going to notice what they communicate, which is that the difference between list and MP3 really just might be sort of within the random sampling variation around these things, whereas it does look like cards is maybe a little bit outside the difference, and there actually is a difference there, even with the confidence intervals built in. Right, I can study that longer and get more information, and that's really what we're getting at with this idea of hierarchical presentation. Give people the most important piece of information in a way where they can just quickly latch onto it, but give them other pieces of information that if they study the graph for a little bit longer, they're gonna be like, oh, that's there as well. And in an ideal world, if you really nail this correctly, what you're able to do is anticipate the next question. Right, so I picked up the first pattern, and then I'm going to ask myself, but what about confidence intervals? And the next thing I should notice when I'm looking at that graph is, oh, but they do have the confidence intervals in there, and I can answer that question. And then I ask a third question sort of mentally in my head, and if I look, oh, there it is as well. And so being able to kind of anticipate how your audience is going to read through that graph and what they're going to want to know, and even in what order they're going to want to know it, is a difficult skill, requires a lot of thought. But really, if done effectively or done well, creates very effective graphics.